you might notice these are a little bit different. Okay, and what's the difference? Usually I'm used to having 3 terms, right? Because I'm always looking for like what number like multiplies to this, adds to this, that kind of junk, right? But here I only have 2 terms. So the thing is, I can write this as 3 terms. And I want you to observe patterns where you don't have to do this. But look, let's kind of do it the long way first so you can see why things work. I need 2 numbers. Look, there's nothing out in front here, right? So I know how to factor something like this. I just need 2 numbers that multiply to negative 81 and add to 0. So what are the numbers that multiply to negative 81 and add to 0? Well, the only kinds of numbers that add to 0 are like 5 and negative 5, 3 and negative 3, the opposites, okay? And remember, when I'm multiplying to a negative, I need a positive and a negative. So this is perfect. I need these 2 numbers to be the same, and I need them to be the square root of 81, right? Because look, I'm gonna just give you the answer. It's 9. Positive 9 times negative 9 is negative 81. Positive 9 minus 9 is 0. So this is my answer. Now what I want you to observe is there's a pattern here, okay? This times this equals this. This times this equals this. And there's a positive and a negative, okay? So that's going to always be true, all right? So what that looks like, here, look, I have like this problem. Now this has a number out front, but the same is going to be true. This times this is going to equal this, and they're going to be the same, okay? Why are they going to be the same? Because the only way that they end up canceling and creating this 0 in the middle is, look, when I multiply this out, I get x times x, that's x squared. Here I get negative 9x. Here I get positive 9x. And here I get negative 81, right? So this is what happens when I multiply it out. And these end up becoming a 0 and canceling. So that's why I end up with only 2 terms. So the only way that happens, though, is if this and this are the same. And so the only way to make sure that's the case is that this and this are the same, and this are the same, only with different signs. Okay? And notice I happen to put the positive first in both of these, but look, I'm going to switch these so you can see. It doesn't matter. Okay? These are going to be the same 2 terms, but the signs are going to be different. So what can I multiply by itself and get 9x squared? Well, the square root of 9 is 3. So 3 times 3 is 9. And x times x is x squared. So 3x times 3x is 9x squared. Now for 49, what can I multiply by itself and get 49? The square root of 49 is 7. So this is 7 times 7. So look, this is the answer. If I multiply it out, look, I get 3x times 3x, that's 9x squared. 3x times 7, that's plus 21x. This is minus 21x. And this is minus 49. And you see this is what becomes 0 and leaves me with just the 2 terms. Okay, so there's a pattern here. It kind of always solves out the same way. Now here, you look at this and you're like, wait a second, there isn't something like here, like there is something that multiplies to 9, right? 9 is what's called a perfect square. 3 times 3 is 9. Same with 49, same with 81. These are all perfect squares. There's a number that multiplies. But you might look at this and be like, crap, there's not a number that multiplies by itself to get 20 or to 125. And what you have to realize is, oh, there's a greatest common factor here. What's a number that multiplies to both 20 and 125? Well, for 20, let's see, the factors are 20 and 1, 10 and 2, 5 and 4. So 20 doesn't multiply to 125, right? It doesn't end in a 0, so it can't be 20 or 10. What about 5? Oh yeah, 5 does multiply. So let's take out a greatest common factor. 5 times 4 is 20. And 5 times what is 125? You can use your calculator if you need to. 125 divided by 5, and you get 25. And now look, now you have something where, oh, this is a perfect square and this is a perfect square. So we're going to set this up. We know it's going to be this times this is this, and this times this is this, and we're going to have 1 positive and 1 negative. So what multiplies by itself to get 4? That'd be 2, and because I have an x squared, it's going to be 2x times 2x gets me 4x squared. And then for 25, it's going to be 5 and negative 5. All right? And there we go. Your turn to try.